Look up at the night sky on a clear evening, and you'll see countless stars, distant planets, and perhaps even the faint glow of a neighboring galaxy. But what if I told you there's a galaxy out there that defies everything we thought we knew about how the universe works? A spiral galaxy so bizarre, it appears to be spinning in two opposite directions at the same time. This isn't some trick of the light or a flaw in our telescopes. It's a real, documented cosmic anomaly that has left scientists scratching their heads for decades. Welcome to the mind-bending mystery of NGC 7674, a galaxy that challenges the very laws of physics as we understand them. Picture this, a majestic spiral galaxy, its arms gracefully swirling through space, just like our own Milky Way. But here's where things get strange. While most galaxies rotate in a single, unified direction, NGC 7674 seems to break all the rules. One side spins clockwise, while the other spins counterclockwise, as if some unseen cosmic hand reached in and twisted it in half. How is this even possible? What forces could be at play here, warping the fabric of space itself to create such a spectacle? This isn't just a curiosity, it's a window into the hidden mechanics of the universe, a clue that there's so much more to learn about how galaxies form, evolve, and sometimes defy all expectations. Today, we're going on a journey to unravel this cosmic riddle. We'll explore the cutting-edge science behind this galactic oddity, from the mind-blowing theories that attempt to explain it to the groundbreaking observations that first brought it to light. Along the way, you'll discover how something as seemingly impossible as a galaxy spinning in two directions could actually exist, and what it teaches us about the chaotic, awe-inspiring nature of the cosmos. So buckle up, because by the time we're done, you'll never look at the night sky the same way again. The universe is far stranger, far more mysterious, and far more wondrous than we ever imagined, and NGC 7674 is proof. Let's dive in. It all started in 1996, when a team of astronomers pointed their telescopes toward a seemingly ordinary spiral galaxy 400 million light-years from Earth. At first glance, NGC 7674 looked like countless others, its elegant arms swirling gracefully through the darkness. But as they analyzed the data, something impossible emerged. The outer regions of the galaxy were spinning in the exact opposite direction of its core, as if some invisible force had reached in and twisted it like a cosmic corkscrew. This wasn't just unusual, it defied everything scientists thought they knew about how galaxies move. The discovery sent shockwaves through the astronomy community. Galactic rotation isn't random, it's governed by gravity, with entire systems spinning in one unified direction like a vast celestial whirlpool. Our own Milky Way, for example, rotates smoothly, with stars, gas, and dust all moving in harmony. But here was NGC 7674, breaking all the rules. Theories flew fast and furious. Could it be the result of a cataclysmic collision with another galaxy? Or was something even stranger at work, a hidden law of physics we hadn't yet uncovered? What made this finding even more remarkable was the technology behind it. The astronomers weren't relying on blurry images or vague measurements. They used cutting-edge instruments capable of mapping the motion of stars and gas with astonishing precision. The data was undeniable. One side of the galaxy spun clockwise, the other counterclockwise, a contradiction written in the stars themselves. It was like watching a river flow upstream while the downstream current raged in the opposite direction. Nature simply didn't work this way, or so we thought. This wasn't just a puzzle for astronomers to solve. It was a wake-up call, a reminder that the universe still holds mysteries beyond our wildest imagination. Every time we think we've figured out the rules, something like NGC 7674 comes along and turns the textbook upside down. And that's the beauty of science. It's not about having all the answers, but about asking the right questions. So what could possibly cause a galaxy to spin in two directions at once? The hunt for answers was just beginning. To understand why NGC 7674 is such a cosmic oddity, we need to start with the basics of how galaxies usually spin. Picture a vast whirlpool in space where billions of stars, gas clouds, and cosmic dust all move together in one smooth, coordinated dance. That's the norm for spiral galaxies like our Milky Way. Their rotation begins when gravity pulls together massive clouds of gas and dust, and as these materials collapse inward, any slight initial motion gets amplified into a sweeping spin, like an ice skater pulling their arms in to twirl faster. Over billions of years, this rotation stabilizes, with everything from the outermost stars to the innermost core moving in the same direction, governed by the unshakable laws of angular momentum. But here's where things get interesting. While most galaxies follow this predictable pattern, NGC 7674 throws the rulebook out the window. Imagine watching a carousel where half the horses gallop clockwise while the others race counter-clockwise. It shouldn't be possible, yet there it is, spinning defiantly in the cosmos. Astronomers call this phenomenon counter-rotation, and it's one of the rarest behaviors ever observed in a galaxy. What makes this even more baffling is that counter-rotation isn't just a minor quirk. It's a full-scale rebellion against the gravitational forces that usually keep everything in sync. So how does this happen? One leading theory suggests a violent cosmic collision might be to blame. If a smaller galaxy merged with NGC 7674 at just the right angle, it could have injected a clump of stars and gas spinning the opposite way, like pouring cream into coffee and stirring in the opposite direction. Over time, this opposing motion could have spread, creating the bizarre dual spin we see today. Another possibility is that the galaxy's outer regions formed from material captured later, perhaps from intergalactic space, with its own built-in spin fighting against the original rotation. But here's the twist: not all counter-rotating galaxies fit neatly into these explanations. Some show pockets of opposite spin deep in their cores, while others, like NGC 7674, display this chaos on a grand scale across their entire structure. This tells us that the universe has more tricks up its sleeve than we've uncovered. Every time we think we've pinned down the rules, galaxies like this one remind us that gravity, motion, and cosmic evolution are far more complex and far more fascinating than we ever imagined. Scientists have been scrambling to explain the impossible dance of NGC 7674, and their leading theories sound like something straight out of a cosmic thriller. The most dramatic explanation points to a violent galactic smash-up in the distant past. Picture this: a smaller galaxy, perhaps 1/10 the size of NGC 7674, comes careening through space on a collision course. As the two galaxies merge, the intruder doesn't just blend in quietly, it slams in at a bizarre angle, dumping a massive clump of stars and gas spinning the opposite direction into the mix. Over millions of years, this cosmic traffic jam could have created the opposing spins we observe today, like two whirlpools crashing together and stubbornly refusing to synchronize. But here's where it gets even more intriguing. Not all counter-rotating galaxies show signs of a violent merger. Some appear too pristine, too undisturbed for such a catastrophic explanation. That's led researchers to consider a subtler culprit: the slow, stealthy theft of intergalactic gas. Imagine NGC 7674 drifting through a cloud of loose hydrogen floating between galaxies. If this gas had its own slight spin, perhaps nudged by the gravity of a passing neighbor, it could have been captured by the galaxy's outer regions, gradually building up enough momentum to oppose the original rotation. It's like pouring water into a spinning bucket, but the new water swirls the opposite way, creating a battle of currents on a galactic scale. Then there's the wild card, dark matter. This invisible, mysterious substance makes up most of the universe's mass, and its gravitational influence could be warping the galaxy in ways we don't yet understand. Could an uneven distribution of dark matter be tugging on different parts of the galaxy, forcing some regions to spin backward? It's a tantalizing possibility, but one that's nearly impossible to test directly, at least with today's technology. What's fascinating is that none of these theories fully explain every detail of NGC 7674's bizarre behavior. Some models predict the counter-rotation should fizzle out over time as gravity smooths everything into harmony. Yet here we are, observing this cosmic contradiction millions of years later. Others struggle to account for how the opposing spins manage to coexist without tearing the galaxy apart. It's a reminder that the universe doesn't owe us tidy explanations sometimes. The most thrilling discoveries are the ones that refuse to fit into our neat little boxes. And that's exactly what makes NGC 7674 so extraordinary. It's not just a puzzle to solve, it's a challenge to everything we thought we knew about how galaxies live, evolve, and sometimes spectacularly defy the rules. The mystery of NGC 7674's bizarre rotation might have an invisible culprit: dark matter. This enigmatic substance, which makes up roughly 85% of the universe's mass, doesn't emit light or energy, yet its gravitational grip shapes galaxies on the grandest scales. Normally, dark matter acts like cosmic scaffolding, holding galaxies together and guiding their rotation into orderly, predictable patterns. But what if, in the case of NGC 7674, dark matter isn't playing by the rules? Some astronomers suspect that an irregular, lopsided distribution of dark matter could be tugging on different parts of the galaxy with unequal force, creating a gravitational tug of war that twists its rotation into chaos. Think of it like spinning a pizza dough in midair. Normally, it rotates smoothly in one direction, but if you suddenly grab one side of the dough while someone else pulls the opposite side, the rotation becomes unstable. Some parts might even start spinning backward. Now imagine that invisible hands are doing this to an entire galaxy. Dark matter's uneven influence could, in theory, warp the galaxy's motion over billions of years, forcing some regions to spin clockwise while others spiral counterclockwise. It's a radical idea, but one that highlights just how little we truly understand about dark matter's role in shaping the cosmos. The challenge is proving it. Dark matter, by its very nature, refuses to be seen or measured directly. We only detect its presence through its gravitational effects, like watching an invisible hand bend the path of stars. In NGC 7674, researchers have mapped the galaxy's visible matter meticulously, but the dark matter's distribution remains a ghostly outline. If future telescopes could somehow chart the unseen mass around this galaxy, they might reveal whether pockets of dark matter are clustered in ways that could trigger counter-rotation. Until then, this theory remains a tantalizing what-if, a reminder that the universe's greatest mysteries often lurk in the shadows. What makes this possibility so thrilling is its implications. If dark matter can twist galaxies into such strange configurations, what else is it capable of? Could other cosmic oddities, galaxies that warp, split, or move in ways that defy logic, also be the work of dark matter's invisible hand? Every strange galaxy we discover pushes us to rethink the hidden forces stitching the universe together. And that's the real magic of NGC 7674. It's not just a puzzle to solve, it's a doorway into the vast, uncharted territory of all we don't yet know. Studying a galaxy like NGC 7674 is like trying to read a book from 400 million miles away while wearing foggy glasses. The sheer distance creates a cascade of challenges for astronomers, forcing them to rely on clever workarounds and indirect clues just to piece together what's happening. Take redshift measurements, for example. As the galaxy moves away from us, its light stretches into longer, redder wavelengths, much like the Doppler effect that makes a siren's pitch drop as it speeds past. By analyzing this shift, scientists can estimate how fast different parts of the galaxy are moving relative to Earth. But here's the catch: these measurements are incredibly delicate. A tiny error in calibration or atmospheric interference could skew the data, making it seem like one side of the galaxy is spinning backward when it's actually just a hiccup in the observation. Then there's the problem of resolution. Even our most powerful telescopes struggle to capture fine details at such mind-boggling distances. Imagine taking a photo of a spinning pinwheel from the other side of a football field. It's hard to tell which way it's turning, let alone if different sections are spinning in opposite directions. To compensate, astronomers combine data from multiple instruments, from radio telescopes mapping hydrogen gas to space-based observatories catching X-rays. Each dataset is like a single piece of a jigsaw puzzle, and fitting them together requires painstaking precision. But perhaps the biggest hurdle is time. Unlike lab experiments where conditions can be controlled, studying galaxies means playing the ultimate long game. A single observation captures just a fleeting snapshot of a process that unfolds over millions of years. To fill in the gaps, researchers turn to supercomputer simulations, recreating NGC 7674's possible history with equations that simulate gravity, gas dynamics, and even dark matter's invisible pull. These digital experiments let them test theories like galaxy collisions or gas accretion by rewinding and fast-forwarding cosmic time. Yet even the best simulations have limits. They rely on our current understanding of physics, which might not account for every twist in this galactic enigma. What's remarkable isn't just the ingenuity behind these methods, but the humility they demand. Every breakthrough comes with a reminder of how much we still don't know. NGC 7674 isn't just a scientific challenge, it's a lesson in patience, pushing astronomers to refine their tools, question their assumptions, and embrace the messy, unpredictable beauty of the cosmos. And that's what makes each new discovery, each hard-won piece of data, so extraordinary. NGC 7674 might be the most striking example of a galaxy spinning in two directions, but it's far from the only cosmic rebel. Take NGC 4550, a galaxy in the Virgo cluster that also defies the norm with its counter-rotating stars. While NGC 7674's opposing spins span its entire structure, NGC 4550 presents a different twist. Its stars are neatly divided into two populations, one rotating clockwise, the other counterclockwise, like dancers in a perfectly synchronized but opposing ballet. This variation hints that counter-rotation isn't a one-size-fits-all phenomenon. Instead, it might arise from multiple cosmic scenarios, each leaving its own unique fingerprint on a galaxy's motion. Then there's NGC 7217, another oddity where gas clouds in the outer regions whirl backward relative to the stars. What makes these cases so valuable isn't just their strangeness, it's the clues they offer when examined side by side. For instance, NGC 4550's dual star populations suggest a quieter, more gradual origin, perhaps from absorbing smaller galaxies or stray stellar streams over eons. Meanwhile, NGC 7674's large-scale counter-rotation points to something more dramatic, like a violent merger that sent shockwaves through its structure. By comparing these galaxies, astronomers are piecing together a cosmic detective story, searching for shared triggers or environmental conditions that could explain why some galaxies flip the script. One tantalizing pattern emerging from these studies is the role of a galaxy's surroundings. Many counter-rotating galaxies, including NGC 4550, reside in dense galaxy clusters where gravitational interactions are frequent. It's possible that these crowded cosmic neighborhoods increase the chances of galactic collisions or gas theft, both of which could seed opposing spins. But outliers exist, two galaxies with counter-rotation isolated in relatively empty space, forcing scientists to consider alternative mechanisms like turbulent gas accretion or even the lingering influence of ancient, now vanished companions. The real breakthrough would be finding a universal rule behind these exceptions. Do all counter-rotating galaxies share a hidden commonality, or is this a case of cosmic chaos where random events produce similar-looking oddities through entirely different paths? Every new discovery adds another piece to the puzzle, pushing astronomers closer to answering whether these galaxies are cosmic accidents or the inevitable results of processes we're only beginning to understand. And that's the beauty of studying anomalies. They don't just challenge our assumptions. They force us to ask better questions, refining our understanding of the universe one spinning enigma at a time. Galactic collisions are among the most spectacular events in the universe. Cosmic car crashes that unfold in slow motion over millions of years. When two galaxies collide, it's not like two solid objects smashing together. Instead, they're more like vast clouds of stars, gas, and dark matter, swirling through space until gravity tangles them into a chaotic dance. The aftermath can leave a galaxy forever changed, its structure twisted, its motion scrambled. And if NGC 7674's bizarre dual rotation really did come from a past merger, it would be a stunning example of how these violent encounters rewrite the rules of cosmic motion. Picture the scene: two galaxies, each hundreds of thousands of light years across, drifting closer over eons. As their gravity begins to pull them together, tidal forces stretch them like taffy, flinging stars into long, shimmering arcs. Some stars might get ejected entirely, cast adrift into intergalactic space. Others settle into new, erratic orbits, their paths no longer following the galaxy's original spin. Gas clouds slam together, triggering bursts of star formation that light up the collision like fireworks. And when the chaos finally settles, what remains could be a galaxy spinning in ways that defy logic, just like NGC 7674. We've seen this play out elsewhere in the universe. Take the Antennae galaxies, a pair of spirals locked in a violent merger about 45 million light-years away. Observations show their stars and gas flung into wild, intersecting streams, with pockets of material spinning in opposite directions. Over time, these galaxies will likely settle into a single, scrambled system, their once orderly rotations forever altered. Then there's Messier 87, a giant elliptical galaxy with a jet of superheated plasma shooting from its core, a relic of a past merger that sent its central black hole into a frenzy. These examples prove that collisions don't just reshape galaxies, they leave behind fingerprints of their violence for billions of years. But here's the catch: not every galactic collision leads to counter-rotation. Some mergers smooth out over time, blending their spins into a single, unified motion. Others might create warped disks or irregular shapes without any backward spins at all. So why would NGC 7674 end up with such an extreme split? The answer might lie in the angle of impact. A head-on collision is more likely to erase rotation entirely, while a glancing blow, like one galaxy sideswiping another at a sharp angle, could inject a clump of material spinning the opposite way. It's like throwing a rock into a spinning car tire. Depending on how it hits, the rock could either slow the tire down or send it spinning backward. The implications are profound. If mergers can produce galaxies like NGC 7674, then these cosmic accidents aren't just destructive. They're creative forces, forging bizarre new configurations that challenge our understanding of physics. Every counter-rotating galaxy we discover is a reminder that the universe doesn't follow a tidy script. Instead, it's a place of chaos, beauty, and endless surprises, where even the most violent events can leave behind something astonishingly unique. Gas swirls through galaxies like the lifeblood of the cosmos, shaping their destiny in ways we're only beginning to understand. In most spiral galaxies, this gas flows in a unified direction, fueling star formation in predictable patterns. But NGC 7674 isn't most galaxies. Here, the gas behaves like two rivers crashing head-on, with opposing currents colliding in a cosmic tug of war. This chaotic dance doesn't just defy expectations. It could be the key to why some parts of the galaxy blaze with newborn stars while others seem oddly quiet. Picture a vast interstellar highway where gas clouds packed with the raw materials for star birth race along orbital lanes. Normally, these clouds move in harmony, collapsing under gravity's pull to ignite new stars in a steady, rhythmic process. But in NGC 7674, gas streams spin in opposite directions, creating zones where clouds slam together at incredible speeds. These violent collisions compress the gas far more intensely than usual, triggering explosive bursts of star formation. It's like throwing a lit match into a pile of dry tinder. Suddenly, entire regions of the galaxy light up with stellar nurseries, their young stars burning brighter and hotter than those formed under calmer conditions. This might explain why astronomers have spotted pockets of NGC 7674 that look suspiciously young compared to their surroundings. In one region, brilliant blue star clusters, the unmistakable signature of recent star birth, stand out against the galaxy's older, yellower core. Elsewhere, towering pillars of gas glow under the fierce radiation of massive newborn stars, their formation likely accelerated by the galaxy's turbulent, counter-rotating flows. These anomalies suggest that the very forces twisting NGC 7674's rotation are also rewriting its life story, turning it into a factory for stars born under extraordinary circumstances. But there's a twist. Not all colliding gas clouds ignite starbursts. Some may ricochet away, their star-forming potential scattered. This could account for the galaxy's patchy appearance, with some regions brimming with activity while others lie eerily dormant. It's a reminder that chaos isn't always creative. Sometimes it's just messy. Yet even this unevenness holds clues. By mapping where stars are born and where they aren't, scientists can trace the invisible battle between the galaxy's opposing gas flows, piecing together how this cosmic anomaly sculpts its own evolution. What's truly remarkable is how this dynamic mirrors, and yet upends processes in more typical galaxies. Take the Milky Way, where gas orbits in an orderly fashion, fostering star birth at a steady, predictable rate. NGC 7674 turns that model on its head, proving that when the rules of motion are broken, the rules of star formation break too. This isn't just a curiosity, it's a laboratory for studying how extreme environments shape stellar lives, offering a glimpse into how galaxies might evolve under conditions we once thought impossible. And that's the real magic of this cosmic oddity. It doesn't just challenge our theories, it gives us a front row seat to the universe's most unexpected performances. At the center of NGC 7674, hidden within its swirling chaos, lurks a supermassive black hole, a gravitational monster millions of times heavier than our Sun. Like most large galaxies, this one is anchored by such a behemoth, but here's the twist. Its black hole might not just be sitting quietly. Some scientists suspect it could be stirring the pot, adding another layer of madness to the galaxy's already baffling two-way spin. Imagine a black hole not as a cosmic vacuum cleaner, but as an engine of chaos. As it devours nearby gas and dust, it doesn't just swallow material silently. It can launch searing jets of plasma at nearly the speed of light and whip its surroundings into a frenzy. These jets, often stretching thousands of light years into space, carry enough energy to shove gas clouds around, disrupt star formation, and even alter the motion of entire galactic regions. In NGC 7674, could these violent outbursts be warping the galaxy's rotation, like a blender churning a smoothie into opposing vortices? It's a tantalizing idea, but the evidence is still murky. Then there's the black hole's accretion disk, a glowing, superheated whirlpool of matter spiraling inward. The physics here are extreme. Magnetic fields twist like rubber bands, particles collide at unimaginable speeds, and friction heats the disk to millions of degrees. Under these conditions, the disk doesn't just feed the black hole. It can also act like a cosmic paddle, transferring energy and angular momentum to the surrounding gas. Some simulations suggest that if this process becomes lopsided, say, if the disk wobbles or fragments, it could nudge nearby material into spinning the wrong way. Think of it as a spinning top that suddenly jerks sideways, sending ripples through the galaxy's delicate balance. But here's the problem. While these mechanisms sound plausible in theory, linking them directly to NGC 7674's large-scale counter-rotation is like trying to trace a single raindrop in a hurricane. Galactic dynamics are messy, and isolating the black hole's influence from other factors, like past mergers or dark matter, is a monumental challenge. Even the most advanced simulations struggle to replicate the galaxy's precise behavior, leaving scientists to wonder, is the black hole the mastermind behind this cosmic anomaly, or just a bystander caught in the crossfire? What makes this question so compelling is its stakes. If supermassive black holes can indeed twist galaxies into such bizarre configurations, it would rewrite our understanding of their role in galactic evolution. No longer just silent predators lurking in the dark, they'd be active sculptors, shaping their homes in ways we're only beginning to grasp. And for NGC 7674, that could mean its greatest mystery isn't just how it spins, but who or what is pulling the strings. To unlock the secrets of NGC 7674's bizarre rotation, astronomers have turned to the digital realm, building entire galaxies inside supercomputers. These aren't just simple animations, they're painstakingly accurate virtual universes, governed by the same laws of physics that shape the real cosmos. By tweaking variables like collision angles, gas densities, and dark matter distributions, scientists can replay the galaxy's possible history thousands of times, searching for the scenario that best matches the real thing. It's like rewinding a cosmic crime scene, testing different suspects to see whose fingerprints fit. One groundbreaking simulation suggests a dramatic past. Imagine a smaller galaxy, perhaps 1/10 the mass of NGC 7674, slamming into it at a steep, oblique angle. As the intruder plows through, its gas and stars don't blend smoothly. Instead, they carve a turbulent wake, dragging some of the host galaxy's outer material into a backward spin. Over millions of years, this opposing motion spreads, creating the dual rotation we observe today. The simulation's beauty lies in its details. It predicts exactly where shockwaves would compress gas into star-forming knots, matching the real galaxy's patchy regions of young blue stars. But here's where things get tricky. Not all simulations agree. Some models propose a quieter origin, where NGC 7674 gradually siphoned gas from intergalactic space, gas that just happened to be spinning the wrong way. Like filling a bathtub while stirring the water counterclockwise, this slow accretion could have built up enough backward momentum to tip the galaxy's outer layers into reverse. The challenge: this scenario struggles to explain why the counter-rotation is so perfectly balanced, rather than a messy tangle of conflicting motions. Then there's the dark matter wildcard. Advanced simulations now factor in this invisible substance's gravitational tugs, revealing how lopsided distributions could warp a galaxy's spin axis over time. One recent experiment showed that if dark matter clumps asymmetrically around NGC 7674, it might twist the galaxy's rotation like a hand wringing out a towel. Yet even these cutting-edge models can't yet replicate the galaxy's precise, large-scale duality, proof that some cosmic mysteries refuse to surrender to even our most powerful digital tools. What makes these simulations so valuable isn't just their successes, but their failures. Every mismatch between model and reality forces scientists to rethink assumptions, whether about dark matter's behavior, the physics of gas clouds, or the chaos of galactic collisions. With each iteration, the simulations grow sharper, narrowing the gap between virtual and actual. And that's the real promise of this digital detective work. One day, these pixelated galaxies might finally reveal the truth behind NGC 7674's impossible spin, turning a cosmic paradox into a profound new understanding of how galaxies dance. Magnetic fields weave through galaxies like invisible threads, quietly shaping the fate of charged particles and cosmic dust. While gravity gets all the attention for holding galaxies together, magnetism plays a subtler but equally vital role, guiding the flow of ionized gas, sculpting the paths of cosmic rays, and even influencing where stars are born. In the case of NGC 7674, could these hidden magnetic forces be the missing piece of the puzzle, quietly nudging gas streams into their bizarre, opposing rotations? The idea isn't as far-fetched as it might seem. We know magnetic fields exist in galaxies. Our own Milky Way has a vast, invisible network of them, detected by the way they polarize starlight and align interstellar dust. These fields aren't uniform, they twist and tangle, especially in regions where gas is turbulent or collapsing into new stars. In theory, if NGC 7674's magnetic fields were unusually strong or chaotic, they could act like cosmic rains, steering ionized gas into conflicting currents. Picture a river where underwater currents pull in opposite directions while the surface seems calm. Hidden forces beneath are locked in a tug of war. Some cutting-edge studies have begun exploring this possibility. By analyzing the polarization of light from NGC 7674, researchers have spotted hints of magnetic fields that don't align with the galaxy's primary rotation. Instead, these fields appear to kink and loop in ways that could disrupt the normal flow of gas, potentially creating pockets of counter-rotation. One provocative simulation even suggests that during a galactic merger, magnetic fields could amplify as gas is compressed, generating localized whirlpools of opposite spin. It's like stirring a cup of coffee with two spoons moving in opposite directions. The resulting turbulence defies simple explanation. Yet for all its promise, the magnetic field hypothesis faces major hurdles. Measuring galactic magnetism is notoriously difficult. requiring exquisitely sensitive instruments and painstaking data analysis. Even then, it's hard to prove whether twisted magnetic fields are the cause of NGC 7674's strange behavior or just another symptom of its underlying chaos. Compounding the challenge, magnetic forces are weak compared to gravity, like trying to divert a freight train with a gentle breeze. For them to overpower a galaxy's rotation would require conditions we've never observed elsewhere, pushing the boundaries of known physics. What makes this line of inquiry so compelling is its potential to rewrite the rules. If magnetic fields can indeed sculpt galactic rotation on such a grand scale, it would force us to rethink how galaxies evolve over time. No longer just passive players, they'd emerge as active architects, shaping cosmic structures in ways we're only beginning to grasp. And for NGC 7674, that could mean its greatest enigma isn't just how it spins, but what invisible hands are guiding the dance. NGC 7674 isn't the first cosmic oddity to leave astronomers stunned. It's part of a long, thrilling tradition of discoveries that have rewritten the rulebook of the universe. Rewind to the 1960s, when scientists first detected quasars, distant objects so bright they outshone entire galaxies, powered by supermassive black holes feasting on unimaginable amounts of matter. At the time, their existence seemed impossible, yet today, we know they're fundamental to galactic evolution. Then there's dark energy, the mysterious force accelerating the universe's expansion, discovered in the late 1990s when observations of distant supernova defied all expectations. These breakthroughs didn't just add footnotes to textbooks, they shattered entire chapters, forcing us to rethink reality itself. What makes NGC 7674 so special is how it echoes this legacy of cosmic surprises. Like quasars and dark energy, it challenges a fundamental assumption, in this case that galaxies rotate as cohesive, orderly systems. But history shows us that every time we've declared the universe figured out, it throws us a curveball. Take pulsars, for instance. When Jocelyn Bell Burnell first detected their rhythmic radio signals in 1967, some speculated they might be messages from aliens. Today, we recognize them as rapidly spinning neutron stars, but their discovery reminded us that even the most bizarre phenomena have natural explanations if we're willing to dig deep enough. Then there's the case of dark matter, first proposed in the 1930s when Fritz Zwicky noticed galaxies in the Coma cluster moved too fast to be held together by visible matter alone. For decades, the idea was met with skepticism, until Vera Rubin's meticulous observations of galaxy rotations in the 1970s proved its existence beyond doubt. NGC 7674's strange spin might one day join these milestones, not just as a curiosity, but as a clue to something deeper, perhaps a hidden aspect of gravity, or a new class of galactic interactions we've yet to name. What ties these discoveries together isn't just their strangeness, but their humility. Each one began as an anomaly, a stubborn data point that refused to fit the mold. And in every case, the universe wasn't being capricious, it was waiting for us to ask better questions. That's the real lesson of NGC 7674. It's not just a galaxy spinning the wrong way. It's an invitation to stay curious, to embrace the discomfort of not knowing, and to keep looking up with wonder. Because if history tells us anything, it's that the next cosmic revelation is always lurking in the shadows, ready to upend everything we thought we understood. There's something irresistible about a cosmic rule breaker, and NGC 7674 delivers that thrill in spades. This isn't just a galaxy, it's a rebellion against the ordinary, a celestial maverick that dares to spin backward while the rest of the universe plays by the rules. And that's precisely why it's captured imaginations far beyond the astronomy community. Think about it. From ancient civilizations mapping constellations to modern-day Netflix documentaries about black holes, humanity has always been drawn to the unexplained. We crave mysteries that remind us the universe is stranger, wilder, and more wondrous than our textbooks suggest. NGC 7674 fits that bill perfectly, offering a puzzle that even experts can't yet solve. Part of its allure lies in its sheer audacity. Most cosmic phenomena, no matter how extreme, eventually bow to the laws of physics. Neutron stars may spin blindingly fast, and black holes might warp space-time beyond recognition, but they still follow predictable patterns. NGC 7674, though, it's like watching a car drive backward on the freeway while traffic flows normally around it, an anomaly so glaring it demands attention. This defiance resonates with anyone who's ever questioned the status quo, whether they're amateur stargazers with backyard telescopes or professional astronomers wielding billion-dollar observatories. It's a reminder that nature, for all its elegance, still has tricks up its sleeve. Then there's the universality of its appeal. You don't need a PhD to appreciate the galaxy's strangeness. Its dual rotation can be visualized with something as simple as a vinyl record spinning on a turntable. Now imagine someone reaching over and forcing half the record to spin the opposite way. That visceral, easy-to-grasp weirdness makes it a gateway to deeper cosmic questions. Social media buzzes with artistic renditions of the galaxy, podcasts dissect its mysteries, and classrooms use it to spark discussions about the scientific method. Even outside scientific circles, it's become a cultural touchstone, a symbol of the universe's boundless creativity. But perhaps the deepest reason for our fascination is what NGC 7674 represents: hope. In an era where so much of the cosmos has been catalogued and modeled, it stands as proof that genuine enigmas still exist. Every time we point a telescope at it, we're not just collecting data, we're humbly admitting that the universe hasn't surrendered all its secrets. And that's a feeling as old as astronomy itself. When Galileo first turned his telescope to Jupiter's moons, or when Hubble revealed galaxies beyond our own, they shattered the illusion of a tidy, fully understood cosmos. NGC 7674 carries that torch today, whispering to anyone who will listen that the next great discovery might be lurking just beyond the edge of our current understanding. What makes this galaxy truly special isn't just its bizarre rotation. It's the way it bridges the gap between scientific inquiry and human wonder. It's not merely an object to study. It's a story, a riddle, a cosmic campfire tale that invites us all to lean in closer. And in a world hungry for awe, that's a gift as rare as the galaxy itself. The key to cracking NGC 7674's impossible spin might not lie in our current telescopes, but in the next generation of observatories now coming online. Take the James Webb Space Telescope, humanity's most powerful eye on the cosmos. Unlike Hubble, which primarily captures visible light, Webb's infrared vision can peer through cosmic dust clouds that have hidden crucial details of this galaxy's structure. Imagine seeing the galaxy's opposing gas flows in unprecedented detail, tracing individual star-forming regions along each spiral arm to determine whether they're being forged by colliding currents. Webb's spectroscopic tools could even measure the chemistry of these regions. If the counter-rotating sections show different elemental abundances, it might suggest they originated from separate galaxies that merged long ago. But Webb is just the beginning. The upcoming extremely large telescope with its 39-meter-wide mirror will capture images 16 times sharper than Hubble's. Picture this, spotting individual star clusters within NGC 7674's opposing spiral arms. then tracking their precise motions over time to map the galaxy's gravitational tug of war in real time. This resolution could reveal whether dark matter's invisible hand is truly warping the galaxy's rotation, or if another mechanism is at play. Meanwhile, radio telescopes like the Square Kilometre Array will map the galaxy's hydrogen gas, the fuel for star formation in 3 dimensions, showing exactly where the counter-rotating streams collide and how these crashes trigger stellar birth. Then there's the Nancy Grace Roman Space Telescope, set to launch later this decade. Its wide-field surveys could uncover dozens more galaxies with similar bizarre rotations, answering whether NGC 7674 is a lone rebel or part of a hidden population. Finding others would be game-changing, like realizing your weird neighbor isn't an outlier, but part of a whole community no one noticed before. With enough examples, patterns might emerge. Perhaps counter-rotating galaxies only appear in dense galaxy clusters, or maybe they're all missing certain types of stars. Each new observation would add another piece to the puzzle. The most exciting possibility: these telescopes might catch the galaxy in the act of changing. If NGC 7674's dual spin is temporary, say, the result of a recent merger, we could witness its opposing motions gradually synchronizing over decades of observations. Or we might find evidence that this is a stable, long-term state, forcing us to rewrite the rules of galactic dynamics. Either outcome would reshape our understanding of how galaxies live and evolve. What makes this moment so extraordinary isn't just the technology, it's the timing. For centuries, astronomers could only speculate about celestial mysteries. Now we're on the verge of watching cosmic enigmas unravel in real time. NGC 7674 has guarded its secrets for hundreds of millions of years. Thanks to these revolutionary telescopes, its greatest revelations may be just around the corner. Whenever an astronomical discovery defies expectations, it's tempting to jump to extraordinary conclusions, and NGC 7674 is no exception. Some have suggested its dual rotation could be evidence of alien megastructures, a cosmic engineering project on an unimaginable scale. Others speculate it might reveal a crack in our understanding of physics, a place where the laws of gravity break down entirely. While these ideas spark the imagination, the truth is far more fascinating and firmly grounded in natural phenomena we're only beginning to comprehend. Let's tackle the extraterrestrial hypothesis first. The notion that an advanced civilization could reshape an entire galaxy sounds like science fiction, and for good reason. Even with technology beyond our wildest dreams, altering something as massive as a galaxy would require energy comparable to multiple supernova energy that would leave unmistakable traces across the electromagnetic spectrum. Yet when astronomers scour NGC 7674 for signs of artificial activity, unnatural radio pulses, concentrated heat signatures, or structured light patterns, they find only the chaotic beauty of natural processes. What's more, galaxy-scale engineering overlooks a crucial detail: cosmic timescales. The opposing rotations we observe today began hundreds of millions of years ago, long before any hypothetical civilization could have existed. Then there's the idea that NGC 7674 violates fundamental physics. It's true that its behavior challenges textbook models, but that doesn't mean the textbooks are wrong. It means they're incomplete. History is full of cosmic anomalies initially mistaken for physics-breaking phenomena. Take quasars, once thought to defy energy conservation until we understood their power came from supermassive black holes. Or dark matter, which seemed to contradict Newton's laws until we realized it was hidden mass. Similarly, NGC 7674's motion likely stems from complex but lawful interactions, mergers, gas accretion, or dark matter dynamics that push existing theories to their limits without shattering them. What makes natural explanations so compelling is their predictive power. The galactic merger scenario, for instance, doesn't just explain NGC 7674, it also accounts for other oddities we observe, like warped dust lanes or bursts of star formation at collision sites. Computer simulations based on known physics can recreate counter-rotating galaxies under specific conditions, offering a roadmap to testable predictions. Contrast that with unsupported speculations about alien engineers or new physics, which raise more questions than they answer. This isn't to say the galaxy's mysteries are mundane. Far from it, the real science behind NGC 7674 violent collisions, stolen gas, invisible dark matter, is every bit as thrilling as any sci-fi plot. By focusing on evidence rather than speculation, we honor the true wonder of discovery, not inventing fantasies, but unraveling the universe's genuine, jaw-dropping complexities. After all, nature's imagination dwarfs our own, and NGC 7674 is proof. While massive telescopes and supercomputers dominate headlines, some of astronomy's most exciting breakthroughs begin with backyard stargazers. Amateur astronomers have long been the unsung heroes of cosmic discovery, their keen eyes and modest telescopes often spotting anomalies that professional observatories might miss. Take NGC 7674. Its bizarre rotation was confirmed by professionals, but it was amateurs who first flagged its unusual behavior in wide-field surveys. Armed with nothing more than passion and patience, these citizen scientists scan the skies night after night, creating a vital early warning system for cosmic oddities. What makes their contributions so invaluable is simple: coverage. No research telescope, no matter how advanced, can monitor the entire sky at once. But thousands of amateurs, scattered across every time zone, form a global network that never sleeps. When one observer in Japan notices a faint smudge where none existed before, or a hobbyist in Brazil records unexpected flickering from a distant galaxy, that data gets shared instantly through online platforms like the American Association of Variable Star Observers or the Galaxy Zoo Project. These reports become breadcrumbs leading professionals to investigate further, like the time amateurs tracked strange flares around a supermassive black hole, clues that later helped researchers identify a rare tidal disruption event. The beauty of this collaboration lies in its accessibility. You don't need a PhD or million-dollar equipment to make a difference. Modern software like Stellarium and free data from space telescopes empower anyone with a computer to sift through cosmic archives for undiscovered patterns. Some amateurs even build their own radio telescopes from spare parts, detecting pulsars and gas clouds invisible to optical scopes. Others specialize in astrophotography, capturing high-resolution images that reveal subtle distortions in galaxy shapes, potential signs of hidden dark matter. Perhaps the most inspiring aspect is how these efforts bridge generations and cultures. A retired teacher in Canada might team up with a high school student in South Africa to monitor a variable star, while an entire family in Australia collaborates on classifying galaxy shapes for a university research project. This democratization of science doesn't just accelerate discoveries, it reminds us that the universe belongs to everyone. Every time an amateur's observation leads to a breakthrough, like the discovery of supernova or exoplanets, it proves that curiosity, not credentials, is the real engine of exploration. The story of NGC 7674 isn't just about a spinning galaxy, it's about the collective human effort to understand it. From the professionals analyzing its light spectra to the hobbyists who first noticed something off in their images, each plays a role in unraveling cosmic mysteries. In an era where science can feel distant or exclusive, these collaborations offer a powerful counterpoint, proof that wonder is universal, and that the next great discovery might come from a teenager's telescope or a grandmother's meticulous notebook. The night sky doesn't discriminate, and neither does the thrill of discovery. NGC 7674 isn't just a cosmic oddity, it's a masterclass in how science works. For students diving into astrophysics, this galaxy is the ultimate teaching tool, a living lesson in the messy, exhilarating process of discovery. Picture a classroom where textbooks lay out neat rules about galactic rotation, only for NGC 7674 to waltz in and flip the script. Suddenly, students aren't just memorizing facts, they're grappling with real-world contradictions that force them to question, adapt, and think like scientists. That's the magic of this galaxy. It doesn't just challenge theories. It teaches future astronomers how to confront the unexpected with curiosity rather than certainty. Take the way it appends conventional wisdom about angular momentum. In most astrophysics courses, students learn that galaxies form with a single, unified spin, like a whirlpool stirring in one direction. But NGC 7674 laughs in the face of that simplicity. Analyzing its motion becomes a hands-on lesson in humility, showing how nature often defies textbook models. Professors use its conflicting data to demonstrate the scientific method in action, observe the anomaly, propose hypotheses like mergers or dark matter, then test them against simulations and observations. It's science as it's meant to be taught, dynamic, iterative, and alive with possibility. Beyond theory, this galaxy offers a window into the tools of modern astronomy. Students working with its data get to explore redshift measurements, learning how subtle shifts in starlight reveal motion across unimaginable distances. They might map its hydrogen gas clouds using radio telescope data, or compare Hubble and Webb images to see how different wavelengths unveil hidden structures. These aren't abstract exercises, they're the same techniques professionals use to probe cosmic mysteries. By engaging with NGC 7674, students don't just learn about galaxies, they become astronomers, wrestling with the same puzzles that keep experts up at night. What makes this galaxy particularly powerful for education is its narrative. Science isn't just a collection of facts, it's a story of human curiosity meeting the unknown. When educators share how NGC 7674 stumped researchers for decades, they're not just teaching astrophysics, they're showing that even the experts don't have all the answers. That vulnerability is transformative. A student might start the semester seeing science as a fixed canon, only to leave understanding it as a living dialogue, where every anomaly like this galaxy is an invitation to push boundaries further. The ripple effects extend beyond classrooms. Public lectures and planetarium shows often feature NGC 7674 as a crowd favorite, its striking visuals and backstory captivating audiences of all ages. For young viewers, it's a gateway to STEM, proving that space isn't just about memorizing planet names. It's a frontier of unsolved riddles waiting for fresh minds to tackle them. And for educators, the galaxy is a reminder that the best teaching tools aren't always the ones with tidy answers, but the ones that spark wonder, debate, and the relentless urge to ask, what if? In a world where science education can sometimes feel oversimplified or sanitized, NGC 7674 is a rebel with a cause. It reminds us that the universe isn't here to conform to our expectations. It's here to surprise us, challenge us, and ultimately teach us how much we have yet to learn. And that's a lesson no textbook could ever capture. NGC 7674's mind-bending rotation isn't just fodder for scientists, it's a muse for artists and filmmakers who translate its cosmic dance into breathtaking visuals. Picture swirling brushstrokes capturing the galaxy's dual spirals, or CGI animations that make its impossible spin feel tangible. These creations do more than dazzle. They serve as vital bridges between hard data and human imagination, turning abstract astrophysics into something visceral. Take digital artist Eric Wernquist's rendition, where the galaxy's opposing arms unfurl like ribbons in zero gravity, their motion so vivid you can almost hear the universe's silent symphony. Or the Cosmic Collisions Planetarium show, which used supercomputer simulations to project NGC 7674's chaos onto domed screens, letting audiences feel engulfed by its gravitational paradox. What makes these artistic interpretations so powerful is their ability to simplify without dumbing down. A textbook diagram might label the galaxy's rotation with arrows and equations, but a painter can convey its strangeness through color. Cool blues for the clockwise swirl, fiery oranges for the counter-clockwise tide, instantly communicating tension our brains grasp before our intellect catches up. Filmmakers take it further, adding sound design to cosmic silence, deep, throbbing bass for the pull of dark matter, metallic chimes for stars born in colliding gas streams. These choices aren't just dramatic, they're pedagogical, leveraging our sensory instincts to teach complex science. The collaboration between scientists and artists here is especially poignant. When researchers at the European Southern Observatory shared raw data on NGC 7674's gas flows with animation studios, the resulting films revealed patterns even the astronomers hadn't spotted, proof that creativity and analysis can fuel each other. Some of the most accurate depictions come from artists who pore over telescope spectra, translating redshift gradients into textures that subtly shift from violet to red across the galaxy's disk. Others take liberties, like the viral dual-spin galaxy music video that reimagined the galaxy as a cosmic vinyl record, its opposing rotations synced to a haunting electronic beat. Beyond education, these works tap into something deeper, wonder. A child who sees NGC 7674 rendered as a glowing whirlpool in a storybook might grow up to be the astrophysicist who solves its mysteries. A gamer exploring a fictional universe modeled after its structure absorbs intuitive truths about angular momentum and dark matter. Even abstract installations like sculptor Luke Jerram's glass rendition, where the galaxy's counter-rotating halves twist in suspended tension, remind us that science and art share the same goal: to make the invisible visible and the incomprehensible felt. Perhaps the most striking tribute is how these interpretations evolve alongside our scientific understanding. Early paintings from the 1990s depicted the galaxy's spin as a clean split down the middle, mirroring initial theories of a head-on collision. Modern pieces, informed by newer simulations, show messier, asymmetrical flows, gas streams braiding and knotting where gravitational tides warped them. This dialogue between discovery and creativity mirrors humanity's oldest storytelling tradition, revising the myth as we learn more about the world. In NGC 7674's case, the myth is real, and the revisions are written in starlight. NGC 7674 does more than baffle astronomers. It forces us to confront profound questions about the very fabric of reality. If a single galaxy can spin in two directions at once, what other cosmic rules might we have wrong? This isn't just a puzzle for scientists, it's a philosophical lightning rod, challenging our assumptions about order, predictability, and the limits of human understanding. For centuries, we've viewed the universe as a grand machine governed by immutable laws, but this galaxy whispers a different truth. nature is far wilder, far more inventive than our equations can capture. Think about how we've historically made sense of the cosmos. From Newton's clockwork universe to Einstein's curved spacetime, each breakthrough came with the quiet assumption that beneath the chaos, there's an underlying simplicity waiting to be uncovered. But NGC 7674 defies that expectation. Its existence suggests that reality might not be a neat puzzle with all pieces fitting perfectly. It could be a tapestry of exceptions, where anomalies aren't bugs in the system, but features we're only beginning to recognize. Some philosophers argue this galaxy is a glimpse into what physicist David Bohm called the implicate order, a hidden layer of complexity where what we perceive as contradictions might actually be interconnected threads in a deeper, more subtle pattern. Then there's the humbling question of whether we're even equipped to understand such phenomena. Our brains evolved to navigate a world of medium-sized objects moving at medium speeds, not galaxies spinning in impossible ways. Cognitive scientists point out that human intuition often fails at cosmic scales, where time stretches over billions of years and gravity warps the very fabric of space. NGC 7674 might be a cosmic Rorschach test, revealing less about the universe and more about the limits of our own perception. After all, if a galaxy can rotate in two directions, what other impossibilities are out there waiting to shatter our frameworks? This touches on a fiery debate in the philosophy of science. Is the universe fundamentally knowable, or are some truths forever beyond our grasp? Optimists point to history's track record. Every time we've hit a wall, from quantum weirdness to dark energy, new theories eventually emerge to make sense of the chaos. But skeptics counter that NGC 7674 could be different, a permanent outlier that resists any tidy explanation. The galaxy's stubborn refusal to conform might be a sign that reality isn't just complex, it's inherently messy, with pockets of chaos that no law can fully tame. What makes this debate so electrifying is its stakes. If anomalies like NGC 7674 are exceptions that eventually fold into broader theories, then science remains on its steady march toward deeper understanding. But if they're signs of something more radical, a universe where rules are fluid, or where local phenomena operate outside global laws, then everything from how we model galaxies to how we define physics itself might need reinventing. The galaxy becomes more than an astronomical curiosity. It's a mirror reflecting our deepest questions about certainty, order, and whether the cosmos will ever fit neatly into the boxes we build for it. Perhaps the most profound lesson lies in how we respond to such enigmas. NGC 7674 doesn't just challenge our models, it invites a shift in perspective. Instead of seeing the universe as a problem to be solved, we might start embracing it as a mystery to be explored, where every answer reveals new questions, and where the greatest discoveries often begin with the humbling admission, we don't know. That admission isn't a surrender, it's an opening, a door to ways of thinking we haven't yet imagined. And if a spinning galaxy can teach us that, then its greatest gift isn't confusion, but wonder. NGC 7674's cosmic conundrum isn't just being solved by one team in one observatory. It's a global effort, a testament to how modern astronomy thrives on collaboration across continents and cultures. From the high-altitude deserts of Chile to the frozen plains of Antarctica, telescopes tuned to different wavelengths are piecing together this galactic puzzle, each instrument offering a unique perspective. The European Southern Observatory's Very Large Telescope captures the galaxy's visible light in exquisite detail, while the Atacama Large Millimeter Array in Chile maps its cold gas clouds with radio waves. Halfway across the world, Japan's Subaru telescope peers through infrared eyes, cutting through dust to reveal hidden star-forming regions. And when night falls in Chile, astronomers pass the baton to their colleagues in Hawaii, where the Keck Observatory's lasers correct for atmospheric blurring in real time, ensuring observations continue uninterrupted. This isn't just teamwork, it's a 24/7 relay race against Earth's rotation, with each station adding another stitch to the tapestry of understanding. What makes this collaboration so extraordinary isn't just the sharing of data, it's the merging of methodologies. Russian astrophysicists bring decades of expertise in galactic dynamics, while Indian researchers contribute groundbreaking algorithms to model counter-rotation. Teams in Brazil specialize in analyzing the galaxy's magnetic fields, and South African astronomers use Mercator's radio dishes to trace the faint whispers of hydrogen gas swirling against the current. When these diverse approaches converge, magic happens. A single observation from a telescope in Australia might resolve a contradiction in data from Arizona, or a simulation run on a supercomputer in Germany could predict a feature later confirmed by a space telescope orbiting 1,000,000 miles from Earth. The result, a three-dimensional understanding of NGC 7674 that no single nation, no lone genius could ever achieve alone. This spirit of cooperation extends beyond professional circles. Amateur astronomers worldwide play a crucial role, their backyard telescopes monitoring the galaxy for sudden changes, a flare near its supermassive black hole, or an unexpected brightening that might signal a stellar collision. Online platforms like Zooniverse allow citizen scientists to classify thousands of galaxy images, sometimes spotting anomalies that automated algorithms miss. When a high school teacher in Norway noticed an unusual pattern in NGC 7674's outer arms last year, her report triggered a chain reaction, prompting professionals to redirect precious telescope time for follow-up observations. In this way, the galaxy's mystery has become a shared human endeavor, blurring the lines between expert and enthusiast, between nations and generations. The tools enabling this collaboration are as innovative as the discoveries themselves. Open access databases like the Sloan Digital Sky Survey host petabytes of galactic data, freely available to researchers from Addis Ababa to Zurich. Virtual observatories let scientists in countries without major telescopes analyze observations remotely, while real-time chat platforms host midnight debates between theorists in California and observers in New Zealand. Even language barriers crumble. Astronomy's lingua franca of equations and spectra transcends words, allowing a researcher in Beijing and another in Buenos Aires to collaborate seamlessly on papers that might finally crack NGC 7674's code. But perhaps the most profound lesson lies in what this cooperation reveals about science itself. In an era of geopolitical tensions, astronomy remains a rare frontier where borders dissolve. The same telescopes used to study NGC 7674 also train their lenses on asteroids that might threaten Earth, reminding us that our planet shares a common fate. Every time data crosses oceans or ideas leap between cultures to unravel this galactic riddle, it proves that curiosity knows no nationality, that the urge to understand the cosmos is humanity's oldest and most unifying instinct. NGC 7674 doesn't just spin in two directions, it pulls us together, proving that the universe's greatest mysteries are best solved not in isolation, but in concert. The hunt for galaxies like NGC 7674 has become one of astronomy's most thrilling treasure hunts. Armed with advanced sky surveys and machine learning algorithms, researchers are scouring the cosmos for other spirals that break the rotational rules, hoping these outliers might reveal a hidden cosmic blueprint. The Sloan Digital Sky Survey alone has mapped over 1 million galaxies, flagging dozens with unusual kinematics, some with counter-rotating cores, others with entire arms spinning backward. Each discovery is like finding a piece of a jigsaw puzzle scattered across the universe, where every new oddball galaxy brings us closer to seeing the bigger picture. Take NGC 4622, a spiral in the constellation Virgo with a disk of stars whirling opposite its gas clouds. Then there's UGC 12591, where the inner and outer regions spin like gears grinding against each other. These aren't carbon copies of NGC 7674, but variations on a theme, proof that counter-rotation might be more common and more diverse than we ever imagined. What's fascinating is how each case adds nuance to the mystery. Some galaxies show clean splits down the middle, while others display messy, asymmetrical flows, as if the universe is experimenting with different ways to break its own rules. The search isn't just about quantity, it's about context. Astronomers are cross-referencing these oddities with their cosmic environments, looking for shared triggers. Do counter-rotating galaxies cluster near violent merger remnants? Are they more likely to float in isolated voids where stolen intergalactic gas could twist their spin? Early patterns suggest both scenarios might be true, hinting that multiple roads could lead to the same bizarre destination. The Helix galaxy, for instance, sits in a crowded cluster and shows merger scars, while the isolated Firework galaxy boasts pristine spiral arms, yet both defy rotational norms. This diversity forces scientists to reconsider whether there's a single explanation for these cosmic rebels or a spectrum of mechanisms waiting to be untangled. Instrumentation is revolutionizing the hunt. The Dark Energy Spectroscopic Instrument, with its 5,000 robotic eyes, can measure the motion of thousands of galaxies simultaneously, flagging kinematic anomalies in real time. Meanwhile, citizen science projects like Galaxy Zoo enlist volunteers to classify galaxy rotations in telescope images, sometimes spotting what algorithms miss. Just last year, an amateur in Portugal noticed faint tidal tails around a known counter-rotator, evidence of a past collision that professional surveys had overlooked. These collaborative efforts are expanding the roster of known outliers faster than ever, turning what was once a curiosity into a legitimate field of study. Yet for all the progress, every new discovery seems to raise fresh questions. Why do some counter-rotating galaxies stabilize over time while others, like NGC 7674, maintain their split personalities for billions of years? Could there be an unseen threshold, a size or mass limit that determines whether a galaxy can sustain such chaos? The answers might lie in upcoming projects like the Vera Rubin Observatory's Legacy Survey of Space and Time, which will monitor the sky for a decade, capturing subtle changes in galactic motion that could reveal how these systems evolve. Until then, each oddball galaxy remains a tantalizing clue, whispering that the universe's rulebook is far more flexible and far more fascinating than we ever dreamed. Peering into the heart of NGC 7674 requires more than just powerful telescope. It demands technological wizardry that bends the laws of physics to our will. Take adaptive optics, a game-changing innovation that turns Earth's blurring atmosphere from foe to ally. By firing laser-guide stars into the sky, astronomers create artificial reference points that twinkle in sync with atmospheric turbulence. High-speed computers then deform telescope mirrors up to 1,000 times per second, cancelling out the distortion in real time. The result? Crystal-clear views of the galaxy's opposing spiral arms, sharp enough to track individual star clusters caught in its gravitational tug-of-war. Where Hubble once saw a smudge, Instruments like the Keck Observatory's adaptive optics system reveal intricate webs of dust lanes and glowing gas streams, proof that even 400 million light-years away, no detail is too fine to escape our enhanced vision. But the revolution doesn't stop there. Modern radio telescopes like the Atacama Large Millimeter Array stitch together dozens of antennae to act as a single dish spanning miles. These arrays capture wavelengths invisible to optical scopes, tracing the cold hydrogen gas that fuels NGC 7674's chaotic dance. By combining signals from antennas spread across Chile's high desert, astronomers achieve resolution equivalent to a telescope the size of Earth, letting them map the galaxy's counter-rotating gas down to scales of just a few light-years. It's like upgrading from a weather satellite to a street-level camera, revealing where opposing currents collide and trigger bursts of star formation. The real powerhouse, though, is artificial intelligence. Machine learning algorithms sift through petabytes of data, spotting patterns no human could discern. When trained on simulations of galactic mergers, these AIs can compare virtual collisions to NGC 7674's actual structure, identifying which scenarios best match its twisted kinematics. Other neural networks analyze subtle shifts in starlight to detect hidden dark matter halos or predict where new observations might uncover more counter-rotating regions. Some of the most promising breakthroughs come from generative AIs that create millions of synthetic galaxy mergers in seconds, exploring parameter spaces too vast for traditional supercomputers, essentially running cosmic experiments at light speed. Perhaps the most underrated innovation is the Hubble spectrograph, now enhanced to unprecedented precision. Instruments like the James Webb Space Telescope's NIR spec don't just capture light. They dissect it into rainbows so detailed, they can reveal the velocity of gas clouds moving at mere kilometers per second across unthinkable distances. By measuring Doppler shifts across different parts of NGC 7674, these tools create 3D velocity maps that show the galaxy's rotation in motion, like a weather radar for cosmic winds. What ties these technologies together is their ability to make the invisible tangible. Where astronomers once relied on static images and guesswork, they now wield dynamic models that simulate the galaxy's evolution across billions of years. Tools like the Illustris TNG project don't just recreate NGC 7674's current state, they rewind time to test how it might have formed, then fast forward to predict its future. This isn't just observation, it's time travel by proxy, letting us witness cosmic history unfold from the comfort of a computer screen. Yet for all their power, these innovations share a humble goal: to peel back layers of cosmic mystery with the patience of detectives solving a billion-year-old case. Every pixel sharpened by adaptive optics, every gas cloud traced by radio waves, every pattern recognized by AI brings us closer to answering why this galaxy spins so defiantly and what its rebellion teaches us about the universe's hidden rulebook. The real magic lies not in any single tool, but in how they converge, transforming raw data into understanding and wonder into wisdom. Science often paints itself as a methodical march toward truth, with hypotheses tested and data meticulously gathered. Yet some of history's greatest discoveries, including NGC 7674's mind-bending spin, were stumbled upon by pure serendipity. Back in 1996, astronomers weren't even looking for a galaxy that defied rotational laws. They were conducting a routine survey of active galactic nuclei when the data revealed something impossible. This wasn't the first time chance played cosmic matchmaker. The cosmic microwave background, our universe's baby photo, was discovered because two radio astronomers kept finding persistent static in their experiments, noise they initially mistook for pigeon droppings on their antenna. Even pulsars, the universe's most precise clocks, were first noted as a curious bit of scruff on a graduate student's chart paper. What makes these accidents so transformative isn't just the discoveries themselves, it's how they reveal science's hidden heartbeat. For every planned experiment, there's an unscripted moment where curiosity trumps expectation. When astronomers first spotted NGC 7674's contradictory motion, they could have dismissed it as instrument error. Instead, they leaned into the anomaly, asking not what's wrong with our equipment, but what's wrong with our understanding. That shift from frustration to fascination is where serendipity transforms into progress. It's a lesson written across the stars. Some truths aren't found by staring harder, but by noticing what wasn't supposed to be there. Consider how many pivotal discoveries began as footnotes. Dark matter's existence was proposed because Vera Rubin noticed stars orbiting galaxies too fast, a detail most ignored as a quirk. The first exoplanet was found orbiting a pulsar, a place no one thought to look for worlds. Even the Hubble Space Telescope's famous Deep Field image, which revealed thousands of galaxies in a patch of sky thought to be empty, was considered a risky waste of precious observation time. These moments share a common thread. Breakthroughs don't always come from the questions we ask, but from our willingness to chase the answers we didn't expect. This isn't to downplay rigorous science, it's to celebrate its messy human side. Behind every eureka are years of grinding work, but also the flexibility to recognize when the universe has handed you a gift. NGC 7674 embodies this duality. Its discovery required cutting-edge telescopes and painstaking analysis, yet its significance hinged on someone saying, "Wait, that shouldn't happen." That's the alchemy of serendipity, preparation meeting opportunity, expertise embracing wonder. For amateur stargazers and professional astronomers alike, NGC 7674 stands as a beacon of possibility. Its twisted spirals remind us that the cosmos still holds surprises for those willing to look not just at the stars, but between them. The next great discovery might be hiding in a dataset labeled noise, or in a backyard astronomer's photo flagged as odd. After all, the universe doesn't care about our plans. It whispers its secrets to those patient enough to listen, curious enough to question, and bold enough to believe that the next revolution in understanding could be lurking just beyond the edge of expectation. Exploring the cosmos comes with profound responsibilities, not just to uncover its secrets, but to ensure those discoveries uplift everyone. The same telescopes trained on NGC 7674's mysterious spin also symbolize a far-reaching ethical question: who gets access to the universe's wonders and who gets left behind? Consider the staggering costs of modern astronomy. Building instruments like the James Webb Space Telescope required billions of dollars, while communities worldwide struggle for basic scientific infrastructure. This imbalance isn't just unfair, it risks narrowing our cosmic perspective to only what a handful of privileged institutions deem worth studying. True exploration demands equity, funding for telescopes in developing nations, open data policies that let researchers everywhere analyze observations, and education programs that empower underrepresented groups to join the quest. Then there's the environmental toll. Giant observatories consume massive energy, from the diesel generators powering remote telescopes to the supercomputers crunching galactic data. Chile's Atacama Desert, home to some of Earth's most advanced telescopes, also faces water shortages exacerbated by their construction. Ethical astronomy means innovating sustainably solar-powered instruments, AI to reduce computation waste, and partnerships with local communities to minimize ecological harm. The irony is stark. We scrutinize galaxies millions of light years away while sometimes neglecting the planet beneath our feet. knowledge sharing poses another challenge. Historically, breakthrough data often languished in proprietary archives, accessible only to elite universities. Today, projects like the Sloan Digital Sky Survey have democratized discovery, releasing findings in real time to scientists, students, and even amateur astronomers globally. This shift proves that when we remove barriers, breakthroughs accelerate. A high schooler in Kenya analyzing public telescope data recently identified a rare variable star, proof that talent is universal, but opportunity is not. The ethics extend beyond Earth. As we study NGC 7674's alien dynamics, we're also laying groundwork for future space colonization. Mining asteroids or claiming lunar territories risks replicating Earth's exploitative histories on a cosmic scale. The Outer Space Treaty of 1967 declared celestial bodies humanity's common heritage, but enforcement remains murky. Should a single nation or corporation profit from Martian resources while others watch from afar? These aren't hypotheticals. Private companies already stake claims on asteroid metals, and lunar water ice could become a contested commodity. Ethical frameworks must evolve alongside our technological reach, ensuring space benefits all species, not just shareholders. Perhaps the deepest ethical layer involves our cosmic perspective itself. Indigenous cultures have long viewed the heavens not as empty frontiers to conquer, but as living relationships to honor. The Maori's reverence for Matariki, the Pleiades, or Aboriginal Australian songlines mapping the stars remind us that galaxies hold cultural, not just scientific, significance. Dismissing these worldviews as myth ignores millennia of observational wisdom, like how Polynesian navigators crossed oceans using stellar currents Western science only recently understood. Ethical astronomy listens as much as it looks, recognizing that NGC 7674 isn't just a puzzle to solve, but a story that belongs to every culture under its light. The path forward isn't simple, but it's clear. Building telescopes on sacred lands requires free, prior, and informed consent from indigenous peoples. Funding allocations must prioritize global participation over national prestige. Environmental safeguards should be as rigorous as engineering specs. And every discovery, from a galaxy's spin to an exoplanet's atmosphere, should spark conversations about who benefits and who bears the cost. After all, the universe doesn't belong to astronomers. It belongs to a child in Lagos dreaming of the stars, a farmer in Peru naming constellations in Quechua, and future generations will never meet. NGC 7674's twin spirals mirror our choice. Will we spin in isolation or orbit toward shared wonder? NGC 7674's cosmic defiance hasn't just captivated scientists, it's ignited the imaginations of storytellers, musicians, and game developers worldwide. This galaxy's real-life enigma, spinning defiantly against the laws of physics, has become a muse for creators who thrive on the unexplainable. Take science fiction author Alastair Reynolds' novel House of Suns, where a counter-rotating galaxy serves as the backdrop for a civilization that manipulates spacetime itself. The novel's characters debate whether such a structure could be natural or evidence of ancient alien engineering, mirroring the same questions real astronomers ask today. Reynolds didn't just borrow NGC 7674's aesthetics. He weaponized its mystery, turning astrophysical uncertainty into narrative tension. The galaxy's influence stretches beyond literature. Electronic musician Jean Mitchell-Jarre composed an entire track titled NGC 7674 for his cosmic-inspired album Oxymore, layering synth waves to mimic the sensation of opposing spirals. Listen closely and you'll hear melodies panning left while rhythms pulse right, an auditory illusion of celestial conflict, even video games have tapped into its allure. The indie puzzle game Cosmophony features a level where players navigate a spaceship through a galaxy split into dual spinning zones, a clear nod to NGC 7674's impossible mechanics. These creations share a common thread. They don't just reference the galaxy, they channel its essence, transforming raw scientific anomaly into emotional resonance. What makes this cultural footprint so remarkable is how it blurs the line between fact and fiction. When astrophysicist Dr. Neil deGrasse Tyson featured NGC 7674 in an episode of Star Talk Radio, he didn't just explain its physics, he invited a sci-fi screenwriter to brainstorm plotlines inspired by its contradictions. Their conversation revealed something profound. The galaxy's scientific mystery is indistinguishable from the kind of narrative gold that fuels blockbusters. Imagine a Star Trek episode where the Enterprise encounters a split-spin anomaly, forcing the crew to question whether they've stumbled upon a cosmic glitch or the handiwork of a dimension-hopping civilization. The galaxy's real-life defiance of expectations makes such stories feel eerily plausible. This interplay between science and art isn't one-sided. Creators often consult astronomers to ensure their depictions hold a kernel of truth, while scientists admit that pop culture's bold speculations sometimes spark new research angles. When the video game Elite Dangerous modeled NGC 7674 with scientifically accurate rotation patterns, players bombarded astrophysics forums with questions about counter-rotations, feasibility questions that led to lively debates among professionals. Similarly, a viral TikTok animation of the galaxy's opposing spins, viewed over 12 million times, prompted the creator to partner with a graduate student on an educational follow-up. The result, a wave of young fans who now associate astrophysics with wonder rather than equations. At its core, NGC 7674's pop culture legacy proves that the universe's greatest mysteries don't belong to labs alone. They're collective playgrounds where scientists and artists alike chase the same thrill, the moment when the inexplicable becomes a canvas for human curiosity. Whether through a novelist's pen, a composer's synth, or a game designer's code, this galaxy's rebellion against cosmic norms reminds us that discovery isn't just about answers. Sometimes it's about asking questions so compelling they inspire us to reimagine reality itself. Explaining why a galaxy spins in two directions at once isn't like teaching someone how a car engine works. It's more like describing the sound of a color or the taste of a melody. The very idea defies everyday intuition, forcing scientists to get creative with analogies that bridge the gap between mind-bending astrophysics and lived experience. One popular comparison imagines the galaxy as a vinyl record playing on a turntable, where someone suddenly grabs half the disc and forces it to spin backward. The visual is striking, but it's not perfect. Galaxies aren't solid objects, and their stars don't move like grooves on a record. That's where more nuanced metaphors come in. Some researchers liken NGC 7674's motion to a hurricane where the outer winds swirl opposite to the inner storm, or a coffee cup stirred in both directions at once, creating turbulent eddies where opposing currents collide. These mental shortcuts aren't just helpful, they're necessary, transforming mathematical abstractions into something visceral. Visualizations play an equally crucial role. Static images from telescopes can't capture the galaxy's dynamic chaos, so animators step in, using supercomputer data to craft simulations where viewers can feel the contradiction. In one NASA-produced clip, the galaxy's counter-rotating arms unfurl like ribbons in zero gravity, color-coded to show redshifted gas fleeing from us while blue-shifted streams rush closer. Tools like these don't just illustrate the science, they make it experiential. planetarium shows take it further, projecting NGC 7674 onto domed screens so audiences stand engulfed by its spirals, the opposing motions rendered tangible through immersive 3D. For many, this is the light bulb moment, when a concept that seemed impossibly abstract suddenly clicks because they can see the paradox in motion. Yet even the best analogies and visuals have limits. Simplify too much and you risk misleading. Compare the galaxy's spin to a carousel spinning both ways, for instance, and people might assume its stars are rigidly locked in place rather than flowing like water in a whirlpool. Focus solely on the beauty of simulations and the underlying physics. Gravity's grip, angular momentum's rules gets overshadowed. Striking the right balance means embracing a paradox of science communication. To make the unfamiliar relatable, you sometimes have to lean into its strangeness rather than sanding it down. When astrophysicist Dr. Clara Sousa Silva explains NGC 7674, she starts by admitting, "This shouldn't be possible by everything we know, and that's why it's so exciting." That frankness invites curiosity rather than pat answers, turning confusion into a shared starting point for exploration. The stakes are higher than just solving a cosmic puzzle. Public engagement fuels everything from research funding to the next generation of scientists. A child who sees a viral animation of NGC 7674 might grow up to build the telescope that finally cracks its mystery. Meanwhile, voters weighing space policy deserve explanations that respect their intelligence without drowning them in jargon. That's why the most effective science communicators borrow tricks from storytellers framing the galaxy as a rebellious protagonist in an epic of discovery, or weaving its enigma into broader narratives about dark matter and galactic evolution. The goal isn't to dumb things down, but to build bridges between equations and wonder, between experts and the public, between a galaxy 400 million light-years away and the human mind struggling to comprehend it. What makes NGC 7674 such a rewarding challenge is how it mirrors science communication itself. Just as the galaxy's dual spins force us to rethink cosmic rules, explaining it pushes us to invent new ways of sharing knowledge. Every analogy, visualization, or planetarium show is an experiment, a test of how to translate the universe's complexity without losing its awe. And in that sense, the galaxy's greatest lesson might not be about astrophysics at all, but about humility. Some truths are so vast, they demand not just our telescopes, but our creativity. There's something deeply humbling about staring into the heart of NGC 7674. This isn't just a scientific curiosity, it's a mirror held up to the human condition, reflecting our insignificance and our boundless curiosity in the same breath. Imagine standing under a clear night sky, tracing the galaxy's conflicting spirals with your eyes, knowing you're witnessing a cosmic rebellion that defies explanation. That moment of awe isn't just about astronomy. It's about confronting the vast, unsettling beauty of a universe that refuses to conform to our expectations. The galaxy's dual spin becomes more than a puzzle. It's a visceral reminder that for all our knowledge, we're still just beginning to scratch the surface of reality. This emotional resonance isn't accidental. Throughout history, cosmic anomalies have stirred something primal in us. Ancient cultures saw gods and myths in the stars, while today, galaxies like NGC 7674 evoke a different kind of reverence, a mix of wonder and existential vertigo. Astronomer Carl Sagan once described Earth as a pale blue dot, a speck lost in the cosmic dark. NGC 7674 takes that idea further, showing us a universe where even the fundamental rules we take for granted can bend, twist, or shatter entirely. It's both thrilling and terrifying, like discovering the ocean you've been sailing has depths no one ever imagined. What makes this galaxy so emotionally potent is how it straddles the line between knowable and unknowable. Most scientific discoveries eventually slot into a framework, offering closure. But NGC 7674 lingers in the liminal space between understanding and mystery, embodying the tension that drives all exploration. It's the same feeling a child gets peering into a dark forest, equal parts fear and fascination, the urge to step forward, warring with the sense of something far larger than yourself. That duality is why the galaxy captivates not just researchers, but poets, philosophers, and anyone who's ever looked up and felt small. There's a profound loneliness to this cosmic perspective, too. NGC 7674's light took 400 million years to reach us, meaning we're seeing it as it existed before vertebrates crawled onto land. By now, the galaxy may have settled into a mundane rotation or torn itself apart. We'll never know in our lifetime. That temporal disconnect underscores our isolation in the cosmos, yet paradoxically, it also connects us. Every human who's ever wondered about the stars has shared this same view, the same questions, the same ache to understand. The galaxy becomes a bridge across time, linking ancient stargazers and future astronomers in a single, unbroken chain of curiosity. But here's the twist: for all its alien strangeness, NGC 7674 also feels oddly familiar. Its contradictions mirror our own inner conflicts, the way we can hold opposing ideas in our minds, or how progress often comes from challenging the status quo. The galaxy's defiance of cosmic norms is, in a way, deeply human. It's a celestial underdog, spinning its own path despite the universe's expectations, and that rebellious spirit resonates. We see ourselves in its struggle, our own small acts of defiance against life's inertia. Perhaps that's the real gift of cosmic mysteries like this one. They don't just expand our knowledge, they expand our sense of possibility. NGC 7674 whispers that the universe is richer, weirder, and more generous with its secrets than we dare assume. It invites us to sit with the discomfort of not knowing, to find joy in the questions themselves, and in a world obsessed with answers, that might be the most revolutionary lesson of all, that sometimes wonder is enough. What if NGC 7674 isn't just a cosmic oddity, but a crack in the foundation of physics as we know it? Some theorists dare to suggest this galaxy's impossible spin might be the first clue to forces or dimensions beyond our current understanding. Imagine a universe where gravity isn't the only sculptor of galactic motion, where unseen strings from higher dimensions tug at matter, or where dark energy's repulsive force behaves differently in certain regions of space. These aren't just wild guesses, they're serious considerations born from the galaxy's stubborn refusal to follow the rules. When conventional explanations fall short, science's greatest breakthroughs often emerge from these very gaps in understanding. Take the concept of hidden dimensions, a cornerstone of string theory. In some models, our familiar three-dimensional space is just a slice of a far richer cosmos, with extra dimensions curled up so tightly we can't perceive them. Normally, these dimensions remain elusive, their effects vanishingly small. But what if NGC 7674 sits where these dimensions leak into our reality, warping spacetime in ways that manifest as contradictory rotation? It's a stretch, but not unprecedented. Think of how Mercury's wonky orbit hinted at general relativity's curvature of spacetime before Einstein formalized it. Sometimes nature's anomalies are breadcrumbs leading to deeper truths. Then there's the dark matter enigma. We've long assumed this invisible substance interacts solely through gravity, but what if it also exerts some unknown force? Picture dark matter particles with a hidden charge, creating electromagnetic-like effects on galactic scales. In NGC 7674, uneven distributions of such particles could generate torque, twisting different regions in opposite directions. This idea gains traction from recent studies suggesting certain dwarf galaxies move as if dark matter interacts with itself, a finding that, if confirmed, would upend decades of assumptions. Of course, not all speculations point to new physics. Some argue the galaxy's mystery might resolve through refinements to existing theories, like modified Newtonian dynamics. This framework tweaks the laws of gravity at low accelerations, eliminating the need for dark matter. While controversial, it's had surprising success predicting galaxy rotations, except in cases like NGC 7674, where it too falls short. That very failure could be a clue. Perhaps the truth lies somewhere between current theories and something entirely new, a synthesis waiting to be discovered. What makes these possibilities so electrifying isn't their likelihood, it's their reminder that science thrives at the edge of the unknown. Every time NGC 7674 defies prediction, it whispers that our maps of reality are still incomplete. The next Einstein or Curie might be staring at its data right now, sensing the outline of a revelation just beyond reach. After all, the universe has never been content to fit neatly into our models. Its greatest gifts come wrapped in paradox, waiting for those bold enough to unwrap them. NGC 7674's peculiar dance isn't just a celestial quirk, it's a cosmic conversation starter. This galaxy, spinning defiantly in two directions at once, does more than puzzle astronomers. It redefines what we consider possible. Every time we think we've grasped the rules of galactic behavior, this cosmic rebel winks at us from 400 million light-years away, whispering that the universe still holds cards it hasn't shown. What makes this discovery so extraordinary isn't just the science, it's the way it binds us together in shared curiosity. From the researchers debating its origins to the artists painting its spirals, and the viewers like you pondering its secrets, NGC 7674 reminds us that wonder is universal. The true magic lies in how this galaxy transforms the unknown into a collaborative adventure. Think about it, its counter-rotation has sparked international telescope projects, inspired citizen scientists to comb through data, and even motivated kids to ask, how does that work? That's the power of a great cosmic mystery. It doesn't just belong to experts in lab coats. It belongs to anyone who's ever looked up at the night sky and felt that tug of awe. And here's the thrilling part, we're just getting started. With next-generation tools like the Vera Rubin Observatory and the Square Kilometre Array coming online, the next chapter of this story might reveal twists we can't yet fathom. Maybe we'll uncover a hidden population of similar galaxies, or detect some exotic physics warping space-time itself. But beyond the data and the diagrams, NGC 7674 offers something even more valuable, a lesson in humility. In an era where algorithms claim to predict everything from the weather to human behavior, this galaxy stands as a monument to the universe's stubborn creativity. It refuses to be pigeonholed, and that's exhilarating. Science isn't about having all the answers, it's about asking better questions. And right now, this galactic enigma is asking some of the best ones we've got. So what's next? Whether you're a seasoned space enthusiast or just dipping your toes into the cosmos, you're part of this journey. Hit like if you're as captivated as we are, subscribe to keep exploring these mysteries together, and drop your wildest theories in the comments. Maybe your idea will be the spark that leads to a breakthrough. The universe is vast, strange, and endlessly surprising. And thanks to oddballs like NGC 7674, we're reminded that the next great discovery isn't just out there, it's waiting for us to look.